Hi, this is going to be another example about exploring the moment and also known as torque. So here is our bar, and there are two forces, F1 and F2. They actually happen to be equal as 100 Newton. And there are several points here. Point A and B, C and D, and the dimension is given. Between AB is 0.1 meter, this is 0.15, and this is 0.1 meter. Okay, so this problem, they have asked us there are two forces. In the previous example, there are three forces, and we are trying to find the sum of the moment of the three forces rotating about 1 point, like 1 point, right? That point is O. And here, this one is just a step up. They ask you to find the sum moment of a moment. Also, same concept about point A. Okay, we can do that, right? And also, they said, how about those forces is not rotating about A, now this is times rotating about B? Sure, because you can actually rotate this force at arbitrary point, right? And then you can also find out the sum of the moment rotating about C and D. So you have 4 of those moments to solve. But however, the concept for each one of the 4 is going to be the same one you did last time, which means you have to find about, for example, first one we want to find the moment rotating about A. In order to do that, we want to find the moment of F1 rotating about A. We also want to find F2 rotating about A. There are two forces. Find each one of them, and then we can go ahead find summation of them just by adding them together, right? So that's our logic. Let's go look at the first one, F1 rotating about A. You notice F1 going through point A. We've seen that before. If that going through point A, the moment of arm is 0 because this force going through the point, then that's 0. Now let's look at F2. It's rotating about where? A. So while using the formula, it's F2 times moment of arm. We're going to use our blue to draw the moment of arm. So it's this force F2 rotating about A. So from rotational point to the force have to be what? Perpendicular. So that's going to be our D. What's our D value here? If we call that D1. So F2 is 100 Newton. Moment of arm is basically here equal to D1. D1 is 0.1. Now let's think about rotation. That's our last checkpoint, right? So this force is rotating about A, and it's orbiting around it. So that's going to be clockwise. So that's going to give us negative. So be aware there's a negative sign for that. That will give us the value of negative 10 Newton meter. Okay. All right, be aware the book, they didn't have negative sign of it. Personally, I prefer to put negative in front of it because in the book, they are considered clockwise in that one to be positive. It's confusing, right? So because in the futures engineer courses, we always consider counterclockwise as positive. So go with this. All right. Now, knowing that, we're going to add them together. So it's 0 minus 10. That gives us negative 10 Newton meter. So you solved the first one already. That's sum of all the moment rotating about A. Now, 1 down, 3 to go. But it's fairly easy. You want to find this moment rotating about B. First step, F1 rotating about B and F2 rotating about B. Then add them together. That's our logic. All right, let's go look. F1 rotating about B. What will be the moment of arm? So it's from B because rotational point is B now, no longer A. That's the difference. Rotational point is B. And from B to the force, perpendicular. That's going to be D2. And did you realize that? That D2 is also 0.1, which is equal to D1. So that's going to be your F1 times D2. F1 is 100 Newton, and our D2 is also 0.1, right? And how about rotation? It's F1 rotating about B. So if I were to isolate that, F1 is here, rotating about B. B is relative at that position. F1 rotating about B. That's what? Clockwise rotation. That's going to be negative. So, negative 10 Newton meter. Now let's look at F2 rotating about B. Well, there's not much rotating to it because it's point B is on the force. So that's going to be 0. We've seen it again. And add them together, those two together, you get negative 10 Newton meter. Okay. Now let's look at our third problem. All those moments rotating about C. So in other words, we need to find the force 1 rotating about C. F2 rotating about C. And then sum them all up. That's our logic. Now go back. Our F1 is here, rotating about C. C is here. If we were to draw this moment of arm in orange color, it's going to be from C. Perpendicular to this force will have to be from here to here. That's going to be our D3, right? So F1 times D3. What's our force 1? It's 100 Newton. And our D3 is going to be 0.1 plus 0.15. No, don't forget our last checkpoint. Positive or negative, right? So this force F1 is somewhere here. It's rotating about C. C is below to make an orbit around. That's going to be clockwise. So that's going to be negative. That, putting in the calculation, that's going to give us negative 25. Now let's look at F2 rotating about C. F2 is here, rotating about C. We need to figure out the moment of arm here. So it's from rotational point C to this force F2 and have to be perpendicular. So that's going to be our D4, our moment of arm. So we'll have F2, the force, times D4. Force is 100, and this D4 from this, it's 0.15. Now thinking about positive and negative, right? So let's take a look. It's this F2 right here, rotating about C and rotating about C. So what do we have? We got it counterclockwise. So that will be positive value. So that's going to be our 15 Newton meter. So knowing that, add those two values together, you will get negative 25 plus 15. That's give us negative 10 Newton meter. Okay, very last one. We want to find all the two forces, the moment rotating about D. Okay, same logic. Force number 1 rotating about D, then force 2 rotating about D. Then we add them together. That's our logic. All right, F1 is right here. Now we're rotating about D now. I'm going to use a different color. Let's use green. So F1 rotating about D is going to be from D to the force. It's going to be this. That's going to be our D5. And D5 will be those 3 dimensions add together, right? Okay. So it's F1, rotation moment from D5. F1 is 100 Newton. D5, we said it's add them together. It's 0.1 plus 0.15. And let's go back to C and plus 0.1. Now we need to figure out the direction. So F1 it's F1 rotating about D. F1 rotating about D, and you know that's going to be, so I'm going to draw it right here. F1 rotating about D, and that would be orbiting around. That's what? Clockwise rotation. So that will give us negative value, since clockwise is negative. And add them together. This is 0.45 times 100. That's, I'm sorry, it's not 0.45, 0.35. Okay. Times negative 100, that's negative 35 Newton meter. Now let's look at F2 rotating about D. It's F2 times this moment of arm. F2 is here, rotating about D. And again, I'm going to use the green color. It's F2 rotating about D. So from D, draw a perpendicular distance to F2. So that's going to be our D6. So D6 will be basically 0.15 plus 0.1, right? 100 for the force, we said 0.15 plus 0.1. And now let's figure out the direction. F2 is here, and D is here. F2 rotating about D, it's going to be counterclockwise rotation. That gives us positive. So it's positive value. Then that will give us 25 Newton meter. Then add them together. Negative 35 plus 25. That gives us negative 10 Newton meter. Voila, you finished this problem. Thanks for hanging out with me on this, because this is a summary of how to figure out the moment, and you choose different point, but you're still using the same basic principle. So you have to get the basic principle very clear and apply for every single situation. Once that's crystal clear, your answer will be right. Okay, I'll see you at the next video. Bye now.